Good morning, dear students. I welcome all of you to the chemistry class of 19th January 2021. Today we shall do the revision for the displacement reactions and various applications of the displacement reactions. So let's move forward and understand some of the things about displacement reactions. In the last period, we have studied about the displacement reactions that is done by the water. So, in the last period, dear students, we have studied about the displacement of hydrogen from acid by metals. So in the last period, we have seen that the displacement of hydrogen from acid by the various metals. This is what we have studied into the last period. Now in this period, my dear students, we want to study about the displacement of hydrogen from water by metals. So please understand, my dear students, today we want to study about the displacement of hydrogen from water by metals. We are well aware, my dear students, that water is H2O, which is generally liquid in state. When this water reacts with the highly reactive metals, so let us first study about the highly reactive metals. Highly, can you name some of the highly reactive metals? हाईली रिएक्टिव मेटल्स, बच्चों आप हाईली रिएक्टिव मेटल के नाम बता सकते हैं? एनी वन ऑफ यू? So this, let's not say magnesium, but let's say potassium. So dear students, when this sodium in the solid state, when it reacts with the water, it produces sodium hydroxide and hydrogen gas. And this is how we can write the balanced chemical equation. So please remember, my dear students, that when highly reactive metals react with water, they produce hydrogen gas and they produce hydroxides for them. Same way, my dear students, our potassium solid, also when it reacts with water, this is in the aqueous state and hydrogen gas is in the gaseous state. This potassium also produces potassium hydroxide, and it also produces the hydrogen gas at the same time. So this is how, my dear students, what we can understand from all this is that when highly reactive metals such as sodium and potassium reacts with water, they displace hydrogen from water. Please understand this very important point, my dear students, that they displace hydrogen from water. So here actually what you do is, this sodium displaces hydrogen and this hydrogen gas is being removed. You have seen that if you have CuSO4 and Fe, that gives FeSO4 and Cu. So Cu is being displaced from CuSO4. Same way, this hydrogen is being displaced from water. Hydrogen is being displaced from water, and that is why we have got hydrogen in the elemental form. Elemental hydrogen. So this is even an important displacement reactions where the sodium and potassium metals, they react with the liquid water, and they displaces hydrogen from the water. So this is how we can say that these two metals, sodium and potassium, are highly reactive, and they can even displaces hydrogen from the water. So it is very important point to understand, dear students. Now let us try to, or let us see the reactions. Let us see the reactions of these metals. Reactions of metals like sodium and potassium with water. So how this reaction takes place, what happens when the metal reacts with the uh, metals like sodium and potassium reacts with the water. So dear students, let us watch the reactions of or the reaction of our sodium. Can you see what is written on the screen, बच्चों? डियर स्टूडेंट्स, आपको दिख रहा है आपकी स्क्रीन पे
Yes,
क्या
sir.
लिखा हुआ है? क्या लिखा बेटा? क्या लिखा हुआ है?
Sodium reacts with water.
ओके, तो चलिए देखते हैं. लेट अस सी हाउ सोडियम रिएक्ट्स विद वाटर. आपको अभी जो दिख रहा है स्क्रीन पे कुछ दिख रहा है बॉटल जैसा. आर यू एबल टू सी द बॉटल ऑन द स्क्रीन?
Yes, sir.
Yes, sir.
Yeah, this is what it is there in the bottle is actually sodium metal. This is sodium metal which is present into the bottle, which is kept under the paraffin oil or kerosene oil or diesel or some other oil, because it is highly reactive metal and it reacts with water present into the atmosphere or air. And that is why, my dear students, this sodium metal is kept immersed under the kerosene oil or under the oil or under the diesel or under the paraffin oil. Now let us see how does it reacts with. Please remember that sodium is an alkali metal and its symbol is Na. Its atomic number is 11. When you mix sodium and water, you get a highly reactive exothermic reactions. Now, my dear students, we will see the reaction of sodium with water. Let us see. Let us see what happens. You can see that there is a water inside the vessel. Now we are going to add the sodium metal into it. Let us see what happens when the sodium metal reacts with water. Let us observe it nicely. Let us see what happens. You can see that lots of heat is being produced. See, the sodium metal has started burning. Oh my God, it's a blast. You can see when we add sodium metal, it starts blasting. See in the beaker also, how does it react? So whenever this sodium metal reacts with water, my dear students, so dear students, have you seen this? बच्चों आपने ये देखा? Have you seen this? Please reply.
Yes,
आपके
sir.
आंसर बहुत जरूरी है. Dear students, have you seen this? आपने देखा क्या? क्या हुआ?
Yes, sir.
क्या
Yes,
आपने
sir.
देखा? क्या हुआ? What has happened?
Blast.
Blast क्यों हुआ? Why there was a blast?
Because sodium reacts vigorous with water.
Very good, wonderful answer. Vigorous reaction आपने कैसे देखा? How you observe there is a vigorous reaction?
Large amount of heat energy is evolved.
Very good. तो चलिए बच्चों, let us write the notes. You can see I am writing for you. When sodium reacts with water, huge amount of heat is produced. This huge amount of heat which is produced, my dear students, that cause an accident or a blast. Please remember, my dear students, that when sodium reacts with water, a huge amount of heat is produced that can cause an accident or blast. So this is how we can understand about the reaction of sodium, with water. So this type of reaction is generally known as an exothermic reactions, in which there is a huge amount of energy is released. Now, what precaution should we take when we allow the reaction, or how sodium is stored? How sodium is stored? Can you answer this question? And why? What is the reason? Dear students, can you answer this question? How sodium is stored and why?
Sodium is stored in kerosene because it reacts vigorously with moist or water.
Very good. So we can write the answer. You should even write with me. Sodium is stored immersed in the kerosene oil or paraffin oil, immersed in the kerosene oil or paraffin oil, or you can keep it into the diesel, or you can any other oil. Why? Because to prevent the contact of sodium metal with moisture in the air. So when sodium is stored immersed in the kerosene oil or paraffin oil or diesel or any other oil, to prevent the contact of sodium metal with moisture in the air, because sodium or potassium being highly reactive metals, they react vigorously with water and huge amount of energy is produced that can cause blast or accident. To prevent harm due to blast or accident, sodium is kept immersed into oil like kerosene, petrol, diesel, or paraffin oil, etc. So I hope, my dear students, it is well understood to you, and you can easily write any kind of answers, or if any such question is being asked to you. बच्चों, समझ में आ गया पूरा? कुछ है ऐसा जो समझ में नहीं आ रहा तो पूछ लीजिए. Hello, dear students. We can write the reactions now in this way, that sodium solid, when reacts with water H2O, which is liquid, it produces 2 moles of sodium hydroxide, 2 NaOH, aqueous, plus H2 gas, plus heat. Please remember, my dear students, that this heat is caught by hydrogen. So your hydrogen catches the heat. Heat is caught by hydrogen gas, and that is what it leads to the blast or accident. So this is how, my dear students, we can explain why there is an accident or a blast when the sodium metal is burning into the water. So please, I hope, my dear students, now you understand the reaction of sodium with water. Remember, when sodium reacts with water, it reacts with liquid water too. Now please remember that this is a displacement reactions. This is a displacement reaction. You can see that heat is produced during these reactions. So we can write heat is produced. Heat is produced in this reaction. It means it is an exothermic reaction. It is an exothermic reaction. One more thing is being proved here. What can we prove here? Or we can say that it is proved, it is proved that sodium and potassium are highly reactive metals. Please understand, my dear students, that it is proved over here that this sodium and potassium are highly reactive metals, and these metals can be cause blast, and they react vigorously with water. Please remember, we have in the last period studied that metal reacts with acid, metal reacts with acid, it produces metal salt and hydrogen gas. So same way, if, my dear students, even sodium reacts with acid like HCl, it produces NaCl and hydrogen gas. So this is how we can write. Even our potassium reacts with HCl or hydrochloric acid. It produces hydrogen gas. Even, my dear students, instead of HCl, if we take sulfuric acid, right, it gives us K2SO4 plus hydrogen gas. And if there is sodium, then the sodium is going to give us Na2SO4, sodium sulfate, and hydrogen gas. So please remember, my dear students, that what we have studied into the previous class is even true for this sodium and potassium metals too. Okay? And then now we have learned something new, that highly reactive metals, when they react with these highly reactive metals, my dear students, when they react with the water, these highly reactive metals, when they react with the water, they also produce hydrogen gas, and their hydroxide mostly. So the hydroxide what they produced is, like for sodium it is sodium hydroxide, for potassium it is potassium hydroxide, and for any other matter. So please remember, my dear students, that we can write highly reactive metal plus water, that gives metal hydroxide plus hydrogen gas. So highly reactive metals, they can react with water and produce hydrogen gas. Now let us see which are the metals that can react with water and produce hydrogen gas. So if you write the question, let us write the question for this. Name the metals that can react with water and produce hydrogen gas. So my dear students, if we answer these questions, we can write the name of the metals like sodium, potassium, then we have calcium, then we have magnesium, then, my dear students, we have aluminium and iron. These are the metals that can react with the water. Please remember that sodium and potassium reacts with all kind of water. Calcium can react with water. Calcium can react with water. Magnesium reacts with only hot water. Please remember, magnesium can react with the hot water. Whereas, my dear students, this aluminium and iron, they can react with steam. That is H2O gas. This is hot water only. They can magnesium can react with only the hot water. Yes, our calcium can react with the water which is liquid, and our sodium and potassium can also be react with the water when it is in the liquid form. So these are the name of the metals that can react with water. And my dear students, whenever they react with water, they do the same kind of reactions and produce hydrogen gas. So now let us start studying about the reaction of calcium with water. Reaction of calcium with water. Dear students, when calcium reacts with water, hydrogen gas is produced. So let us write the chemical equation for this reaction. Calcium plus 2H2O, that gives us calcium hydroxide, definitely CaOH twice, plus hydrogen gas. Now this hydrogen gas bubbles. The bubbles of hydrogen gas they stick to the calcium metal, stick themselves or stick to the calcium metal. Now as this calcium metal gets stuck with the bubbles of hydrogen gas, this calcium metal starts floating, in the water. So this is what you can remember, my dear students, that when calcium reacts with water, hydrogen gas is produced along with calcium hydroxide. We can say calcium is solid, water is liquid, calcium hydroxide, let's say it's aqueous, and hydrogen is produced as a gas. These bubbles of hydrogen gas sticks to the calcium metal, and thus calcium metal starts floating. Please remember that the calcium metal starts floating in the water. So this is how this calcium metal starts floating into the water whenever, my dear students, this this calcium reacts with the water. Now let us look into the reaction of magnesium with the water. What happens when magnesium reacts with water? Reaction of magnesium with water. Reaction of magnesium with water. So my dear students, when magnesium reacts with water, let us see what happens. Whenever magnesium reacts with water, my dear students, but it is very much necessary that the water must be hot. It produces magnesium hydroxide, MgOH twice, and produces hydrogen gas. So our magnesium is solid in state, water is in the liquid state, magnesium hydroxide what we get is in the aqueous state, and hydrogen what we produce is in the gaseous state. Please remember, my dear students, this is also a displacement reaction. This is a displacement reaction. So magnesium displaces hydrogen from water. Now what you need to remember here is this water must be hot water. So please mind well here, it is an important note that magnesium does not react. Magnesium does not react with cold water, but reacts with hot water. Now again the same thing happens even in this case, my dear students, that these bubbles of hydrogen gas sticks to the metal, and thus, my dear students, this metal, magnesium metal, starts floating into the water. So this is how we understand the reaction of magnesium with water. Please, my dear students, when we compare these reactions of magnesium and calcium with water, we realize that they react exactly in the same manner with water. They both produce their hydroxides and they produce hydrogen gas. This hydrogen gas bubbles, they stick with the water, and this calcium also start floating. Same as magnesium hydroxide, calcium hydroxide is also formed, and this calcium also start floating in the water. The only difference is this. This is the only difference, that magnesium can react with hot water, whereas calcium can react even with the cold water. So this is how we can differentiate, or this is how we can understand the difference between the